9.6 is a combination of 9.2 through 9.5. So in 9.2 we learned about parabolas, and you could see the equation of a parabola. 9.3 was circles, and then we just learned 9.4 and 9.5. At the end of the 9.5 video, I taught you guys how to tell an ellipse and a hyperbola apart from the equation. So what I told you guys is for an ellipse and a hyperbola, all you do is look at the x squared and the y squared, and if one is positive and one is negative, it's a hyperbola. If they're both positive or both negative, it's an ellipse. And this was only true if they were on the same side of the equation. Now, a circle looks a lot like an ellipse. X squared and y squared, they'll either both be positive or they'll both be negative. But then in addition to that, they'll also both have the same coefficient. So if you see 3x squared plus 3y squared, that's a circle. And we'll review that more when we do some examples. Okay, a parabola. Parabola is probably the easiest to identify. If only one of the letters is squared, then it's a parabola. So if both x and y are not squared, only one of them is squared, it's a parabola. Alright, so number one, first thing I notice, x isn't squared. So number one is a parabola. So when you have a parabola, look at the top of the notes. You're supposed to solve for the letter that doesn't have a square on it. So because x is not squared, we're going to solve for x. We're going to divide both sides by -3. So that gives us -1/3 y squared equals x. And I'm going to move it around. Alright, so for parabolas, you want to solve for the letter that is not squared. And then you might have to complete the square. Okay, so they want the equation in standard form. Next thing we're going to do is graph the equation. So to graph this one, I'm going to use the lattice rectum method. You might want to review the 9.2 videos if you don't remember. So the lattice rectum, there are two ways to find how long that is. One way is take the distance from the vertex to the focus and multiply by 4. Now, we don't know where the vertex or the focus is right now, so the other way to find the length of the lattice rectum is figure out the a value. So on this problem, the a value is -1/3. The lattice rectum is equal to 1 divided by the absolute value of a. So 1 divided by, and the absolute value of -1/3 is +1/3. 1 divided by 1/3 is 3. So this parabola has a lattice rectum that is 3 units long. Alright. So looking at the equation, we could tell that this parabola does not, or has a vertex at 0, 0 because it does not have parentheses and it doesn't have an h out here. So this is a sideways parabola and it has a vertex at 0, 0. So here's our vertex. And if I'm going to use the lattice rectum to graph it, I need to know where the focus is. So dVF, that means distance from vertex to focus. dVF is 1 over 4a. So the dVF is 1 over, and then 4 times 1/3 is 4/3. And to divide by a fraction, you flip and you multiply. So the distance from the vertex to the focus is 3/4. All right, I also know this opens to the left because the a value is negative. When the a value is negative, it's either down or to the left, and this is a horizontal parabola, so it's left. All right, so 3/4 of the way, or 3/4 units to the left, that is where the focus is. And then we know the lattice rectum is 3 units long. So because it's 3 units long, that means it goes 1.5 units up, and it goes 1.5 units down. Okay, so now I'll make my parabola in green. And I'm okay with only 3 coordinates if you use the lattice rectum method. Alright, what else did they want in the directions? We found the equation in standard form. We didn't identify it, so let me write that down. This is a parabola, and we know that because the x is not squared. Alright, so standard form, identify it, and graph the equation. Looks like we're done with number 1. Okay, number 2. So this is a circle. We know it's not a parabola because they're both squared. X has a square and y has a square. We know it's not a hyperbola because one of them would be negative if it was a hyperbola. So it's down to ellipse or circle. And I know it's a circle because they both have the same coefficient. They both have a 1. Okay, so I need to put this in standard form. I'm going to put the x's together first and leave a gap. I'm going to put the y's together. And we don't have to complete the square for y because there's no y to the first power. So I'm only going to complete the square for the x. Take 6 divided by 2, that's 3. And square 3, you get 9. Add 9 to the other side. So if I factor that trinomial, I get x plus 3 squared plus y squared equals 16. And we don't divide by 16 because it does not have to equal 1. It only has to equal 1 for hyperbolas and ellipses. Alright, so I need to write down what it is. It's a circle. And now let's graph our circle. So it is centered at -3, 0. We do the opposite of what we see with the x's. So -3, 0 is our center. Alright, looking at the right side of the equation, there's a 16. The right side of a circle's equation is the radius squared. So if 16 is the radius squared, the radius is 4. So I go up, down, left, and right 4 units. And we make our circle. So again, the center was -3, 0, and the radius was 4. Those are the two things you need to graph a circle. Okay, for number 3, it kind of looks like a hyperbola, but remember, you want x squared and y squared on the same side. So if I move that 100x squared to the left side, now I can see that this is an ellipse. And I know it's not a circle because 100 and 196 are not the same number. They have different coefficients for x squared and y squared. Alright, now an ellipse is supposed to have a 1 on the right side, so we need to divide everything by 1225. So the right side is going to equal 1. On the left side, remember that in the numerator, we don't want there to be a coefficient. So I'm going to take the bottom and divide by the top. So 1,225 divided by 100 is 12.25. But I'm going to write that on the bottom. Then I'm going to take 1,225 and divide by 196. So 1,225 divided by 196 is 6.25. Okay, those seem like ugly numbers, but they're actually pretty nice. And the bigger denominator should go first, and 12.25 is the bigger denominator, so I put that first. Alright, so the reason those aren't bad numbers, 12.25, the square root of 12.25 is 3.5. The square root of 6.25 is 2.5. So these are actually really nice numbers. Alright, so this ellipse is centered at 0, 0 because there are no parentheses on top. Underneath x, we see 12.25. And again, the square root of 12.25 is 3.5, so we go 3.5 to the left and to the right. Underneath y squared is 6.25. The square root of that is 2.5. And we don't make the box because this is an ellipse, not a hyperbola. Alright, so number 3 should be done. Did we do everything? We identified it, equation in standard form, and we graphed it. Okay, number 4 looks like a circle. So if I put the x squares on the same side, so I added 3y squared to the left side. I'm also going to move the 6y to the other side. So that's going to become positive. Then I'll leave the 9 where it was. Alright, so I know this is a circle because they're both squared, they're both positive, and they both have a 3 in the front. So that makes it a circle. If that was a negative in between, it would be a hyperbola. Okay, so now we don't have to complete the square for the x's because there's no x to the first. But we do have to complete the square for the y's. So first thing we should do, take out the 3 in the front. 6y divided by 3 is 2y. Now we complete the square only for the y's. 2 divided by 2 is 1. 1 squared is 1. Now that 1 is really a plus 3, so we add 3 to the other side. So we have 3x squared plus 3, and we're going to factor y plus 1 squared equals 12. Divide everything by, we're not going to divide by 12. Again, we don't want the right side to be 1 for a circle. We want to divide by 3 because for a circle you don't want coefficients in front of x squared and y squared. So this is going to give us x squared plus y plus 1 squared equals 4. So there's standard form of the circle, and we just need the center and the radius, so we could graph it. Center is 0, comma negative 1. The x doesn't have parentheses, so the coordinate's going to be 0, and we do the opposite of plus 1 for the y. The radius equals the square root of 4, so that's 2. Zero, negative 1 is down here, and we go 2 units up, down, left, and right. Okay, looking at number 5, we see 5x squared and negative y squared, so immediately you should be able to tell that's a hyperbola because one of the squared terms is positive and one of the squared terms is negative, and they're on the same side of the equation. Alright, so let's put the x's together and put the y's together. We don't want any coefficients other than 1, so we're going to take out a 5 from the x's and leave a gap to complete the square. We're going to take out a negative 6 from the y's. So negative 12y divided by negative 6 is positive 2y. Complete the square. Negative 6 divided by 2 is negative 3. Square that and you get plus 9. 2 divided by 2 is 1. Square that and you get 1. This made plus 45. This made minus 6. Now we factor our perfect square trinomials. So 5 times x minus 3 squared minus 6 times y plus 1 squared. Okay, 45 minus 9 minus 6, that is 30. Hyperbolas are supposed to have a 1 on the right side of the equation, so we divide everything by 30. Alright, so this is going to become x minus 3 squared over, and 5 over 30 is the same as 1 over 6 minus y plus 1 squared over 6 over 30 is the same as 1 over 5, and this equals 1. Alright, so there's our equation in standard form. Now we just need to graph it. So this hyperbola has a center at 3 comma negative 1. And now we have to do the square root of 6 and the square root of 5. So the square root of 6 and the square root of 5 are both bigger than 2, but they're smaller than 3. So for 6, I'm going to go left and right 2.5. And for 5, I'm going to go up and down, and I'll go about 2.25. And we make our box. Then make the diagonals of the box. This is horizontal because the x is positive, so we go sideways for our hyperbola. Okay, for number 6, this is an ellipse. We can tell it's an ellipse because they're both squared, so that rules out a parabola. There's a plus, they're both positive, so that rules out a hyperbola. And the x squared has a 9 in front, but the y squared has a 1 in front, so that rules out a circle. Okay, so for the equation, we want to do what we normally do, put the x's together, put the y's together, take out a 9 for the x's, 54 divided by 9 is 6. Alright, so now let's complete the square. 6 divided by 2 is 3. 3 squared is 9. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9 again. This 9 is really an 81. And this other 9 gets multiplied just by 1. Now we factor 9 times x plus 3 squared plus y minus 3 squared equals 9. An ellipse is supposed to have a 1 on the right side, so we divide everything by 9. So we know the right side is going to equal 1. These 9s are going to cancel, so this is going to have a 1 underneath. Remember, for an ellipse, the bigger denominator is supposed to go first. So I'm going to change the order. I'm going to put the 9 first. And I'm going to write the 1 underneath because an ellipse is supposed to have a denominator for both. Alright, so we identified it as an ellipse. We have the equation in standard form. So the last thing we're going to do is graph it. This ellipse is centered at negative 3, positive 3. Remember, you have to do the opposite of what's with the x first. And we see a 9 underneath the y. We take the square root of 9, that's 3. So we go up and down 3. And underneath x we see a 1. The square root of 1 is 1, so we go left and right 1. Finally, we draw an ellipse with those 4 outside points. Okay, that's all for the first half of 9.6.